Hello everyone. Now I will discuss about the axis of ECG. See, to understand the axis of ECG, we need to understand one triangle that is called Einthoven triangle. That is very simple thing. Uh, it is here. Suppose here our right hand is placed, and here our left hand is placed, and it is here our left foot is placed, and right foot is new placed for right foot lead is for neutral. Okay. So it is the AVR lead and it is AVL lead and AVL it is the AVF lead. And if we make a triangle by connecting these three leads, this triangle is called Einthoven triangle, and our heart is lying in this triangle. So our rhythm is generating from here. Here SA node is there, and it is conducting via this route. So the vector of the current vector is going via this route. Okay, so everything is positive to AVF. Respective to AVF, it is quite negative, but everything is opposite direction to AVR, so everything is negative to AVR. And respective to AVR, it is positive to AVL. Okay, and between AVR and AVL, here is lead 1, and AVR and AVF, here is lead 2, and here AV here is lead 3 between AVF and AVL. Okay. Sorry. Now if we place the leads like this, these will be like this: lead 1 at 0 degree, and AVF is at 90 degree, and lead 2 at 60 degree, and lead AVR is at 30 degree, AVL is minus 30 degree, lead 3 is 120 degree. Okay, and these are the extension of the leads. These are the negative form of the leads. These are made artificially. Okay, for understanding the further process. See, normally our the axis of heart is minus 30 to 90, means our cardiac axis remains in this part. Okay, and if the cardiac axis comes in this part, means minus 30 to minus 90, that is called left axis deviation. And if it comes between this part, minus 90 to 180, this will minus 90 to 180, this is called RAD, means right axis deviation, and rest is minus minus 90 to 180, this is extended axis deviation. Okay, now how we will calculate the axis. For calculating axis, we will see that we will take two leads, lead 1 and AVF. These are two perpendicular leads. Okay, normally we will see the QRS complex. R is greater than S in both lead 1 and AVF. Okay, so if R is greater than S, it is normal. If S is greater than R in any lead, that is negative. Okay, so I told at first that lead 1 and AVF in both leads, if is positive, means R is greater than S. If R become negative in lead 1, means if it is becomes negative in QRS complex become negative in lead 1 but positive in AVF, that is right axis deviation. And if it becomes positive in lead 1 but negative in AVF, then it is called left axis deviation. Now I will explain you how it occurs. Suppose it is 1 and it is AVF. If it becomes negative in 1, means the vector will be like means vector is this direction, but positive in AVF. So vector will be this direction. So net vector will be like this direction, means it becomes RAD. Okay. So negative in lead 1, positive in AVF is RAD. Now, if it becomes positive in lead 1, so vector will be a direction of the lead 1, and negative in AVF means vector will be opposite to the AVF. So net vector will be like this. This will be in the part of LAD. Okay. So negative in AVF and positive in lead 1 is LAD. Okay. And negative in both AVF and lead 1. So here vector negative in lead 1 and negative in AVF. So vector net vector will be like this, means extended axis deviation. Okay. And in normal, our in last part, it is normal, positive in AVF and positive in lead 1. Net vector will be like this in the region of normal heart axis. Okay. And another thing we do, that we will find the where the isoelectric line is. Sorry, means where the Q is, sorry, where the R is more or less equal to S. Okay. And we will find the perpendicular to that lead, means where the isoelectric is there, the axis will be perpendicular to that. See here, it is in lead to isoelectrical, and so see here, perpendicular to lead to, there are two things. One is AVL and one is negative AVL. Okay. So perpendicular to lead to, there are two things. One is AVL and one is minus AVL. So it may be placed at AVL or at the region of minus AVL. Okay. Now we will see the lead of AVL. So where the at the direction of the AVL, it is positive, means it is towards the AVL. Okay. So it between two options, it is QRS is positive to that direction, where the axis is towards that direction. Okay. Means the here axis is towards AVL, so it becomes towards AVL. Okay. Now the axis is towards the AVL, so it is a case of left axis deviation, because AVL is minus 30 degree. Okay. I am discussing this process again. We will find a isoelectric point. We will find a lead that is limb lead where there is isoelectrical means R is greater, sorry, R is equal to S, and we will and axis is according to the rule, axis is towards that isoelectric lead. Okay, so there may be in, suppose it is going through this it is isoelectrical to these leads. Now vector will be this way or this way, because these two are perpendicular. Now we will see these leads. If these leads become positive, so vector will be this direction, and if the leads become negative, so vector will be the opposite direction, means towards this way. Okay, we are doing this same thing here. We had found that it is symmetrical in lead 2. Now perpendicular to lead 2, there are two leads. One is AVL and minus AVL. So we will found, now we need to determine where the axis is between AVL and minus AVL. So in AVL lead we had seen that QRS complex is positive, so the vector is towards the direction of AVL. If it becomes, if it remains negative in AVL, so we can determine that it is uh, away from the AVL, means means it will be uh, towards the negative AVL. Now we will see the what is the uh, angle of AVL, that is minus 30 degree, and we told that from minus 30 degree it is left axis deviation, so it is a case of left axis deviation. Now we will see by the first method also, it is positive in lead 1 but negative in AVF, it is, so it is a case of left axis deviation. Okay, thank you.